In today's video, we are going to talk about the difference between empirical and molecular formula. So molecular means the true formula, and another way of saying empirical is the reduced formula. Now, why would we want a reduced formula? It's an unfortunate consequence in chemistry. A lot of times when we use chemical equipment to figure out what a particular substance is, like what its chemical formula is, the machines that we use aren't smart enough to figure out how many of each atom are in the molecule, and instead what they give us is they give us a ratio of the atoms in the molecule, so that way, and then we have to then figure out what the actual amount of atoms in each molecule is, just because it's very hard for a machine to determine that. And even to this day, it's still difficult to do. So we do have to do a lot of this in chemistry pretty often. So for example, molecular formula for the H2O2 is a molecular formula. So that's the real formula. The empirical formula for that would just be dividing by its greatest common factor, which in this case is 2. So if I divide both of these numbers by 2, I'm going to get H1O1. The ones are never written, so it's going to be written like that. So just be aware of that. I'm not going to write the ones, or I will write the ones for this part, but after this I'm not going to. So for glucose, the reduced formula, you just take the greatest common factor, which in this case is 6, and divide everything by 6, and you get C1, H2, O1. The ones won't be written, so it would be written like this. For CO2, it can't be reduced any further because there is an unwritten 1 here. So the empirical for CO2 is the molecular because it has a 1 in it, so you can't reduce that anymore. This next one, very common mistake. A lot of students will see this and they'll say, oh, divide it all by 2, and then totally forget that there's an unwritten 1 in front of the P. People see the 2 and the 4 and they go straight to, okay, 2 is the greatest factor, divide it by 2. But in this case, again, the empirical is the reduced because of that 1. And then the last one, C3H6, just divide them both by 3. It would be C1H2, or just CH2 is how it would be written in real life. So that's empirical to molecular, just the basics, like trying to figure out, how to reduce. It's really just a lesson on reducing. There's nothing crazy here. So now we're going to do some of the real problems, which are at the bottom. And they're a little different. So I like using this chart. I kind of came up with this, or I borrowed this from another teacher. But it's basically, you got molecular on one side, you've got empirical on the other, and you've got a multiplier in the middle. Because if you think about it, in order to go from molecular to empirical, you just divided by the greatest common factor. Well, if you wanted to go backwards, you would just multiply by that same number. That's where the multiplier comes in. Once you see me do a few, it's going to be very easy. This is a very simple topic. So number 1, calculate the molecular formula. So we want the molecular formula. The molar mass, that's another way of saying molecular mass, is that. And the empirical formula is C4 or CH4N, right? So here's how it works. The empirical formula goes here. The molecular mass goes on the other side. So now here's what we do. Find the GFM for this empirical formula. Literally do it off to the side. 1C is 12, 4 H's is 4, 1 N is 14. Add it all up and you get 30 grams per mole. So I'm just going to put a 30 there. The units are grams per mole in both cases. Then you figure out the multiplier. What do you have to multiply 30 by to get 60? Well, 2. So if you had to multiply, if the weights are multiples of each other, then the formulas are multiples of each other. So just take this formula and multiply it by 2. So it's going to be C2, H8, N2. Done. Let me explain the really easy part about this. It doesn't matter if you put the molecular on the left and the empirical on the right. It actually doesn't make a difference. As long as you understand that molecular goes on one side and empirical goes on the other, you are always going to get, when you're doing these types of problems, you're either going to get the bottom left and the top right. So you're going to get one mass and one formula, or you're going to get the other formula and the other mass. So it's either top left, bottom right, or bottom left, top right. You're getting both pieces of those information. And if you flip them, as long as you keep them separate, meaning empirical, the reduced version goes on one side and the molecular goes on the other, as long as it doesn't matter if the molecular is on the left or the right and vice versa. Okay, so let's do a few more and hopefully this becomes very, very, very easy. So I'm not going to highlight or anything on this next one. Let's just do the work. So let's see. The molecular formula of ethylene glycol, and if you don't care about any of that, the second sentence is what matters. The molar mass is 93. 93. The empirical formula is CH3O. Figure out the molecular formula. Well, this isn't hard. What does CH3O weigh? Well, you do your GFM. I'm going to save a little time. It weighs 31. You should know how to do GFM. Now, the next thing we're going to do is the multiplier. What do you have to multiply 31 by to get to 93? 3. So, since the formula is if the mass is a multiple of 3, then the formula is a multiple of 3. So, C3H9O3, done. Last, calculate the empirical formula of a compound that has a empirical mass of 30 and a molecular formula of that. So one corner gets a formula, the other corner gets a mass. It is that simple. So all you're going to do with this is you are going to figure out the mass of this one. It's 180. We've done it 100 times, so I'm not even going to do the math. Figure out the multiplier or divider, meaning 180 divided by 6 is 30, or you could say 30 times 6 is 180. Doesn't make a difference. And then that's what you, in this case, since we're going from molecular to empirical, divide everything by 6. So C1, H2, O1, done. That's how you do empirical molecular. Hopefully it was easy.